Hi everyone, in previous video we investigated item 1 and item 2 in effective Java book. In this item, George Bloch mentioned enforce the singleton property with a private constructor or enum type. So of course, overall this course is not for someone new in Java. It's for someone is already know about Java and can code in the Java, and we are teaching the best practices about Java, how you can use it in a best way. If you focus this item, obviously today's role we are using modernized frameworks like Spring Boot, and these frameworks already contains IOC container. So which means we do not think about it, we don't have to think about it, a singleton or HTTP session request lifecycle or some propagation type what we use in Spring Boot, because it's already handled by Spring Boot itself, Spring Framework. All the beans are generated in singleton way in a default. For instance, if you define service annotation on top of the class or component annotation, it will be generated by Spring Boot in a singleton way. So you will use one single object during the whole application lifecycle. If you want to use one object during the per HTTP request, per HTTP lifecycle, so there are different propagation type, you need to use this propagation type. Of course, we don't need to create our own singleton factory pattern or other stuff. It is already handled by Spring Boot itself. However, we have to know how things work under the hoods, and this books explain the best usage way of the Java. And in this item, we will focus lazy initialization, lazy instance creation, eager initialization, eager instance creation mean, and enum instance creation. And these three are very crucial to understand. Let's go back to our coding part and example part. So what I will do again, I will create another package in here, item 3. And then in my example, I will use a caching example. Imagine we have a very simple cache and we are caching objects to our memory. That's why I will create one interface, which is cache interface. And this interface will contain three different methods: get, string key, this should be not string objects, and key object value, and remove key. So these are basic, right? We're gonna use a hash map, and which means you can add something with the key and you can remove something with the key and you can get something with the key. And if you get something, the time complexity will be big O 1, because getting means directly accessing. Okay, so this is all. And now I will first talk about lazy initialization. That's why I will create a lazy cache. In the book, in item 3, George Bloch already mentioned single instance, singleton pattern. So I assume you already know the singleton pattern, but I will also talk about what singleton pattern is. Singleton pattern, basically, you are creating instance of the class only once, and you are using this instance whole life cycle of the application. So this is, I believe, very clear. So how you can do this? If you want to enforce the singleton, you have to use private constructor, because if you are using the private constructor, you cannot access the class outside of the class. So that's why, what are we gonna do? First, we will of course implement this class from cache interface, not serializable. Come on, it's not serializable, sorry. Forget the serializable, it's something else. I will override my methods, and then what I will do, I will basically do this private final map object, that's all, and cache. I will give my field name. And then what I will do, I will create one private constructor block, because if I want to force a singleton, I should have private constructor block. And then I will set my cache map object with new hash map. It's not concurrent hash map, we will come there as well. We will talk about the concurrent hash map as well, but not now. Anyway, so now I have one lazy cache class, and this lazy cache class has three methods: get, put, remove, and it has a cache object. So what can I do in here? I can basically use cache.key, cache.get key, and then what I can do, cache put key the value, and cache dot remove. What I'm gonna remove, I remove by key, right? So which means now I have three methods, and these three methods put, get, remove, adding object, removing object, getting object. So that's understandable. But obviously I cannot access this class outside of the class because it has private constructor. Let's try. We already mentioned that in item 1 in static factory methods, right? But let's try again. Let's say I have main and I want to access my lazy cache, new lazy cache. So obviously, see, I cannot do that because if I go here, it will tell me lazy cache has private access. So which means you cannot access this class. That's why we are forcing to singleton like this. So what are we gonna do? We're gonna do this in lazy initialization. Private final static. No. Private static, not final. It cannot be final. Lazy cache and instance. Right. That's perfect. Now we're gonna create a class. Function. Function means it will be static and it will get my instance. If I don't have the instance, which means if instance is null, create a new instance and return create an instance. If instance is not null, return instance, which means we will initialize this only once and we will return to the client. Lazy cache, basically, we are not allocating a space in the memory. We are just initializing the object when it's called. We call it the lazy cache. It's a similar way in Hibernate lazy fetch. How Hibernate lazy fetch works, when you are calling the object in Hibernate, like a related relational object, Hibernate create a proxy. So this proxy maps everything to lazy object, and it receives, you are receiving from the Hibernate, you are getting the object when it's called, and this enhances the performance of the application. So it's exactly the same way what we are doing. If it's null, don't create this object. If it's null, create this object and return it. If I don't call lazy cache at all, don't create any object, which means do not allocate space in the memory. So this will enhance memory complexity, space complexity. I believe it's clear. Let's talk about the cache, eager cache. Eager cache, unlike lazy cache, it's creating object in advance, which means we don't need to call it to create an object. We are directly creating the object in the compiler when we run the application, right? How? I will do the same way, by the way. I will implement cache interface in here. So again, this should be also singleton. And how we're gonna force a singleton? There are three ways to force a singleton. One is lazy initialization, the other one eager, and the other one is enum. So let's do the eager. Eager, basically, it's very simple. Static, final, eager, new eager cache. That's all. You are creating the instance right away. You are not checking with a function. You are not checking if it's null, create instance and then return. You are creating the instance at once. This has a disadvantage. Disadvantage is it is allocating the space in your memory. But advantage is it's thread safe than the lazy cache. You might ask how the lazy cache is not thread safe. We will focus one example and you will understand the lazy cache is not thread safe. But enum instance creation covers both. It's not allocating the space in the memory and it is fully thread safe. That's why George Bloch recommends you please use enum if you will not use any subclasses, because you cannot extend enum. But by the way, there's a deep note. You can implement enum by a interface. That's something nice. We will talk about it. But let's focus that one first. So I will directly copy paste everything in here because it's easy, right? That's why I'm sorry for that. What I will do, I will create a constructor, but I will delete this parameter. I will not get any parameter, and I will make my constructor again private because it should be only accessible within the class. Why? I want to force it to singleton. I don't want to force it to something else. And now I have one cache object. I already created my instance, and I will also copy paste these functions because they are exactly the same functions and paste in here. What I'm gonna do, I will only create one method, which is get instance, and it's return the instance. This is all of eager cache. Eager cache means create instance right away. It's thread safe. It's very nice, thread safe, but the downside of eager cache is allocating space in the memory, something that we don't want if we don't want to use it. Because imagine you are using core libraries, right? And you are not using all functionalities of all libraries, but imagine that you are the library is creating instance right away and they are allocating space in your memory. This is not definitely something that we don't want it. We're only allocating the space in the memory when we need object. So that's why in this approach you should lazy cache. But of course lazy cache has downside. It is not thread safe. And that moment, George Bloch recommends you in this item, you should use enum instance creation. Force singleton with enum. Let's say enum cache class, right? Enums can be implemented by interface, so that I will do exactly the same way. Why? I don't understand. It's serializable. No, there's no serializable. And I'm sorry, I will again copy paste this methods from here. I will directly copy paste them. I will directly copy paste them. And of course we don't have the cache, and I will also should I copy paste the cache? No, let's create this one. Private final map object cache new hash map object. Actually, I don't need to define object in here because it's already creating the object. And then what I will do, I will only call instance. So this is instance creation in enum. Singleton. We are forcing the singleton pattern with the enum. So this is the best way to create a singleton object in Java because it's thread safe and we are not allocating the space in the memory. But the downside is if you need to extend your enum, the caching mechanism, of course you cannot extend this enum object by the subclasses. So it cannot have the subclasses. So that's the downside of this usage. Let's call them at once and see how are they going to work. Var lazy cache dot get instance. We are calling the instance. Now instance is null and it's going to create a one instance and will return the instance, right? So what I will do, this is lazy cache 1, I will create lazy cache 2, and then you will see exactly the same lazy cache, exactly the same instance. And I will do the same things for eager cache, eager cache instance 1, eager cache 2, and I will get instance and I will compare them. And if you see in here, the IntelliJ IDEA will say it's always true. So you don't need to do that, but it's okay. I just want to show it. And now I will do this enum cache 1, enum cache, and IntelliJ IDEA will say it's always true. Let's look at their hash code as well. System out.println. Yes, and same for eager cache. I want to see their hash codes. Yes, I want to see the hash code them as well. Perfect. Let's run my main class. When I run my main class, oops, it throws an exception in here. Why? Okay, let's do this. So let's run it again. It's previous video thing. Oop, return null. So now I believe it's fine. Anyway, let's come here. So when we run this, we will see lazy cache instance same, true. And you are seeing the same hash code for lazy cache. You are also seeing instance are true for eager cache and hash code are the same. Also, enum cache instance true. So the downside of lazy cache is we said it's not thread safe. Let's test it. How we can test it? It's not thread safe. Like thread example, I will create another class thread example, and I will create my main object, and I will create two threads in here, new threads 1. So what I will do, I will directly do the system.out.println hash codes of lazy cache thread 1, and then I will do system hash codes, no, not lazy, eager cache, eager instance in thread 1, and this will be eager cache get instance hash code. So this is something that I wanted, and then what I will do, the other one is system dot no, not lazy cache, enum cache, eager cache instance, and this will be of course enum cache dot instance cache code. So I will start my this threads, and now I will create another threads because I want to access the single lazy cache instance at the same time with my another thread, and to show you why it's not thread safe. Okay, I hope it's gonna work, because sometimes it is working, sometimes it's not. It really depends on the time matter, but I believe this example will work. Let's see that. So I run it, and you will see in here lazy cache instance in thread 1. See, it's different. Hash code, this hash code and this hash code are two different things. However, in eager cache and enum cache, hash code are exactly the same because both are thread safe initialization. But lazy cache is not thread safe. Why it's not thread safe? Because if you go to lazy cache, so it's in a null in the beginning, right? But we are trying to access the same method from by two threads at the same time, and one thread create one object, another thread create another object, because in that amount of time the lazy cache instance is null. It's not. It wasn't created. If we put a delay to here, for instance, like let's put a delay in here. Delay is 2 milliseconds, right? And you will see same hash code. Do you see the same hash code in here? Because there's a delay, and first thread, first thread, which means thread 2, it already created instance of the lazy cache, and now thread 1 access the instance of the lazy cache, and it's checked. Yeah, there is already one instance. So what I should do, I shouldn't create instance of the lazy cache because there's already an instance. I should use it. So in that matter, as you can see, lazy cache initialization, it's not a thread safe. Eager cache and enum cache initialization is thread safe. You might ask, how can I make a thread safe? Of course, that's a very nice approach. You can do it. It's easy. Yeah, it's easy. Let's say thread safe cache. Right. So it should be also implemented by cache class. You know what I will do? I will directly copy paste everything. I'm sorry, I cannot create the same things over and over again. I'm so sorry for that. So of course, in that time I will use final concurred hash map, because concurred hash map is a thread safe hash map. So that's why I will use a concurred hash map. Of course, my constructor will be the private. I will not receive any parameter. I will directly initialize cache object in the constructor block with concurred hash map, because I want to make it concurred hash map. Which one is the thread safe one? And then what I will do, I will do this private static thread safe cache instance, and I will come here. I will initialize this object using the synchronize keyword. Like I will create a method which synchronize keyword, and which means synchronize keyword, and then it will synchronize and it will be thread safe. Let's try it. And of course, you can also synchronize it within the block or within in the methods. It matters. but for now, let's do it in the method. What I will do, I will go my example and I will do this. System out thread safe lazy cache instance, and I will do this thread safe cache that gets instance hash code. This is thread 1. Oh, sorry, this is also thread 1. There's a typo, and I will copy paste this and paste in here. I will make it thread 2, and I will remove this milliseconds. Okay, so now you will see the thread safe cache has exactly the same hash code, which means it's the same instance. I will run it, and as you can see in here, thread safe cache instance is exactly the same. However, lazy cache, which are without the thread safety, it's not the same. So that's why if you don't want to bother yourself with thread safety, you should use enum cache. That's why George Bloch recommended you to use the enum cache when you want to force Singleton. So that was it. If you want to make sure without synchronize the keyword how it's gonna work, let's do it as well. Remove the synchronize keyword in here and run it our thread example, and you will see two different hash codes. As you can see, there's two different hash codes. It's not thread safe. The thread safety is provided by synchronize the keyword in here. So it's locked object and it prevents race condition. So that was a whole tutorial for this video, and I hope it's very helpful. I hope you understand the differences between eager, enum, and lazy cache. Let's summarize it. Eager cache is thread safe, however, we are allocating a place in the memory. So we don't want to allocating space in the memory because it creates space complexity. Lazy cache is better than the eager cache in that matter, like in space complexity matter. However, it is not thread safe. And enum cache provides, by the way, I full of so far said cache. It's not cache. It's eager initialization. It's lazy initialization or cache initialization. This is the correct term. The enum initialization is much better than eager cache and lazy initialization. Sorry, again, I said cache. Why? Because it's thread safe and it doesn't allocate space in the memory. However, it has a downside. You cannot extend it because you cannot extend enum in the subclasses. So that is a very important and crucial point. And another example is thread safe example, thread safe lazy initialization example. You can use it by using synchronize a keyword. So that was all. I hope it was very helpful. See you in the next video. Thank you for listening.